once again, welcome to Modern Startup. Today we'll be looking at the concept of correlation analysis, and there'll be a need for us to define that concept piece by piece. Now the question is, what is correlation? You don't need to think too far, as the concept has been used even in our elementary mathematics. I believe you must have seen the concept of variation. When we deal with the concept of the direct variation, the inverse variation, the joint variation, and the complex variation in that sense, which you must have perhaps heard about. So that is exactly what we're actually exporting into this particular concept. So what is correlation? Now the correlation is actually a statistical tool which studies the relationship between two variables. Now I have two variables and I want to study the relationship that exists between them. Then what I try to employ is the concept of what? Correlation. But it should not be misinterpreted for that of correlation analysis. For correlation analysis involves what? Involves methods and techniques that are used for studying and measuring the extent of the relationship between two variables, basically. So that is what correlation is, and that's what correlation analysis is. Now, for instance, there are two variables to be studied. We believe in statistics that they are coexisting, or there are existing relationship between these two variables. So we try to check if there's actually a relationship, and if there's a relationship, how strong, or what is the degree of the relationship between them. And like I said, these are things that happen even in our day-to-day activities. That is why we have to tag some people friends, some acquaintance, some best friend. What you have just done is that you had measured the degree of your friendship with such a person or with people. Do you understand? Now what there are types of correlation actually, and the types of correlations involve the positive and the negative correlation. The first one is the positive and the negative correlation. Now, what do we call the positive correlation? The positive correlation tends to be, it talks about the direct relationship, in that when a particular variable, say x, is increasing, then y as well is also increasing. And like I said, it's practical. For instance, we believe that increase in height affects your weight. So the taller you get, the weightier you become. Then the next one is that the increase in income also affect expenditure. As your income increases, your expenditure increase corresponding or relatively. So it's when such an occurrence happens, we refer to such as what? As a positive correlation. But it's still negative when it's happening in the other way around. That is, when a particular variable is increasing and the other is decreasing, then we tag such what? We target a negative correlation. For instance, when the price of a commodity increases, then the demand for that commodity decreases relatively. Although that is not, I will not discuss in the concept of exceptional demand here, but on the norms, that is what actually happens. When you increase the price of a commodity, what happens to the demand? It nosedives, it decreases. So that is what we call the positive and the negative correlation. But when we discuss that of the other type of correlation we have is called the linear and the curvilinear correlation. So the curvilinear actually is otherwise known as the non-linear correlation. So what is the linear correlation? It's called linear when you measure the degree between them having a constant slope. Do you understand? That is to say that as a particular variable is increasing, the other is increasing as well, or as a particular variable is decreasing, the other is decreasing as well. So that such is called a linear relationship, such that it tends to be modeled or patterned after the equation of a straight line. But when it comes to curvilinear, is that the slope when being plotted varies at every junction, at every point. The slope varies. So and it's also called nonlinear, like I said initially. So we cannot the value of one variable cannot with precision predetermine the value of the other variable. So that is what we discuss, or we refer to as the curvilinear correlation. Now, there are, like I said, that in correlation analysis, what we tend to do is that we tend to measure relationship and the degree of that relationship. Now, there are various tools that have been put in place in getting this done. The first is called the scattered diagram. The scattered diagram. The second is called the passing coefficient of correlation. It's another method we employ when studying relationship between variables. Next one is called the two-way frequency table. We have the rank method that involves the Spearman rank method, and we have what we call the concurrent deviation method. Is another method that we employ when we are studying the concept of correlation. But today in this class, we are going to be looking at that of scatter diagram, how we can determine relationship between two variables just by plotting them, just by your sketching or plotting them on a 2D Euclidean space, your Cartesian plane, and studying the pattern by which they follow. So we can say that, oh, such a relationship exists between these two given variables. Meanwhile, before we go into that, it is expedient that we know that when we are dealing with just two variables, let me say that we are dealing with just one variable, say x and y, then we are just talking about a linear relationship. And when we're talking about more than one variable, say that I'm trying to study relationship, study a particular factor considering more than one variables in determining that variable. Let me say variable y, and I have more x's, let's say x1, x2 down to xn, and I want to use those stuff to determine my y. Then we'll talk about multiple correlation or multiple regression. So these are the things we need to know before we dive fully into this class. Welcome back to class. Now, like I said, in this class we'll be dealing with we'll just be facing that of the scatter diagram, in studying relationship between two variables. But meanwhile, you need to also know that in summary, correlation, two variables x and y are said to be correlated if change in one variable leads to corresponding change in the other variable, say y. That is when we say that they are correlated. Otherwise, we can say they are not correlated. So in other words, how do we go about the concept of scatter diagram? Now, we have, number one, they can exist a perfect positive relationship between variable, and there can be perfect negative relationship between variable, even though such are not visible in the real life, in the real sense. But when it comes to pure sciences, we come to realize that such can actually exist. For instance, when you are discussing the concept of Charles' law, where we said that increase in volume is also increase in temperature, affect the increase in temperature. So such is that for Charles' law. But negative occurs when we are dealing with Boyle's law. So we are discussing that of scientists. That one deals with a perfect relationship. For instance, how do I know a perfect relationship? Is that a perfect positive relationship. Now, I have such my Cartesian plane, so that I have my y and I have my x, which can represent anything. You can call it whatever you want to call it. For instance, if, for instance, I have a straight line, after plotting my scatter diagram, I discover that all of these points lies on a straight line, then I am discussing a perfect positive relationship because it goes in the right direction. Now, if it goes in the other way around, such that I have my line coming in this manner, and all my lines are actually falling perfectly, all my dots are falling perfectly on the line, then this is referred to as as my perfect negative relationship. So, but I call it strong positive relationship if all of the points are close to the line. If the points are actually close to the line, like dense around the line, then it is called a strong positive relationship. This is referred to as a strong positive relationship. But it is called strong negative relationship if it is happening the other way around, such that all these guys are clumping around it. Then I call it the strong negative relationship. So these are what we need to note. Note number one is that you need to understand that when all of the points are falling upon a straight line, it is called a strong positive relationship. When all of the points are falling on a straight line in the right direction, but on the left direction, in this manner, it's called the perfect dimension. This is a perfect negative relationship, the perfect positive relationship, the strong positive relationship. Why? Because the points are clumps towards the line, and this is called the strong negative relationship because the points are also clumps towards the line in this sense. Welcome to class once again. Now we have discussed the concept of the relationship that can exist between two variables, say x and y, that can be perfect. And we said such a relationship exists in the field of sciences, where we are studying the concept of perhaps pressure laws, the gas laws, basically. Now, on that note, we have discussed the perfect positive relationship, such that all of the points are on a straight line, and the perfect negative relationship, all of the points are also on a straight line, only that they are on a converse direction. The perfect positive goes upward, and the perfect negative comes downward, but all of the points are on a straight line. Then we have discussed the strong positive and the strong negative, that all of the points are closely dense and closely packed together in a single direction. Same with the positive and the negative. But today or now, we're going to be talking about the relationship between two variables, such that they are widely spread, but in the same direction. So the strength of the relationship is measured by how close they are to themselves. But now they are sparse and they are dispersed amidst themselves. The variation between the variables is significant. So it's called the weak positive relationship, while here is referred as the weak negative relationship, because the points are actually far apart from each other. Then here is called no correlation, in that all of the points do not have a specific direction, not to the right, not to the left. So we refer to such as no correlation. And this is referred to as no correlation as well, and we could call it no linear correlation, in that there is no specific direction that they are passing through. And as you can see, this can have a definite slope to an extent, a definite slope, but this cannot have a definite slope, as their slope change at every point. So we refer to them as no linear relationship or association between them. So far so good. We have discussed the concept of the scatter diagram in studying the notion of linear relationship, of correlation. So in our next class, we'll be looking at another tool that we can use in studying the concept of correlation analysis, and it includes the Karp-Pasing method of studying correlation, and from there we will perhaps take a dive to our regression analysis. Thank you for being a part of this class. Please do ensure you subscribe and share this video with family and friends.